So hello all, if it's Wednesday and it's at noon, we have a new PentaBAR, and this time of a very interesting subject I know very less about, so I need your help in asking questions and gathering to the crowd and making it happen and making it interactive. So today we'll talk about observability in using Amazon Web Services. And this sounds like a fancy word, but what can it really do for you? Can it really prevent bugs or even lower the time required to fix them? Can it prevent a flood on call alerts? And for this, we have with us Florian Chazal, who is a solution architect with Amazon Web Services, and he will be joined by Catalin Dumitras, principal cloud architect at Pentalog, and they will create and they will speak about this subject, and they'll try to define it and see all that's behind the subject, but also through a practical study case and discussing about a problem that this might help. And I'll let the floor to them, but not before asking you to use the Q&A section at any time. So if you have questions, just put your questions in the Q&A. That's how we'll be able to moderate them. If you relate to the problem, if you have specific questions to the problem. So I count on you for the very technical questions and the side. And I'll do I'll put the dummy hat and ask the stupid questions in the room and see how that works in addressing this issue. So Florian, Catalin, welcome to the PentaBAR.
Hello.
Hey.
Thank you.
So how are you today?
Pretty good so far.
How come you're interested in this subject, Florian?
On my side, so I've been in a developer in Alexa team before, and so I was managing a service in production, and I got quite dirty hands debugging issues all along. So that's where I ended up like really being a fan of like all those technologies and stuff around monitoring and observability to really not waste too much time on finding where the issue is exactly and how to fix it quickly.
Nice. And what about you, Catalin?
Well, since I interact with many clients and many teams here at Pentalog, I'm very interested in anything that can help me fix issues faster.
Yeah. Okay.
So
the goal is how to fix issues faster. And I know you have a case on that. Can you maybe set the stage and see what's that about?
Absolutely. So I have an itty-bitty tiny problem. And by tiny, I mean huge. This is Wednesday, and on Monday, we got a new ticket in one of our projects in our Jira board where we have a bug in the shopping cart. And in the shopping cart, one of our wonderful users, who is also a potential investor, can't change the quantity. And it's been 2 days now. Obviously, everybody's keen on fixing this as soon as possible, but I cannot at all replicate the issue. So, Florian, is there anything in AWS that could help me?
Yeah, definitely. Let me share my screen really quick. So before digging into all the details of your specific issue, I just would like to set the stage on a few like basics around monitoring and observability, if you don't mind. So let me.
That will be very helpful.
So as you said, like right now you've got an issue in production. So the question would be like, what's happening really between the beginning of an issue and the end of it? So we all heard of many downtime that big application are having every day. So the first thing you want to do is to detect it. What you mentioned is quite interesting here, because you mentioned that basically here you're waiting for your customer file a ticket and to be aware of a problem. So we're going to see how we can improve this phase first. And then we will want to identify the problem, fix it, and verify that everything has been properly fixed. That would be the standard timeline of an issue. So as you mentioned in your example, so leveraging a user to get you to the point where you detect that there is a bug, this means it's a really long feedback loop, right? You end up by waiting for, I don't know for how long your bug has been in production, potentially for a long time. If it was pushed, for instance, on a Friday and no one saw it before Monday when your site has been started to be used for real, we don't know how many users got it for real, so it can be problematic to rely on users. So I think the first step it would be to put proper metrics and alarm in place. So in a standard system, you would have to monitor all those layers, and you can probably get most of them provided out of the box when using like managed services on any cloud provider, and probably not have to deal with network storage and all that. For instance, if you're working on serverless, you probably don't have to deal with more than your application and data level. But and that will give you like putting alarms and metrics and alarms on those will give you already like a good view of your internal system health. But it would probably not be enough. Like you would having CPU, RAM, and I/O metrics, for instance, even if it's green, does not always mean your system is healthy. And one of the good way to really know the health of a system is to set key performance indicators, so metrics and thresholds based on your business. So is your application actually performing as expected? Even if your monitoring dashboard is all green, are your customer getting the experience you want them to have on your website? Like for instance, in your case, not being able to change the count on a basket might not be really visible at your low-level metrics. So you want to set like business-related metrics, like of your usage of your application, like how many people are signing up, what is the sales rate at the moment, the amount of products sold, and so on. That would give you like a better view of really what is the experience of your system by your customer. So you have like many tools to do that, but here I'm from AWS, so I'm going to just really quickly present the one that I know the best. So you have like CloudWatch metrics and alarms to put those in place. And you can even rely on AI-based services that can cope with trends of your metrics. Like for instance, if your application have like a pattern that is a normal pattern, and so you want to make sure that your trends is understood, you can use like anomaly detection, for instance, to get to have proper thresholds like more accurately. So great. Now that we have business and technical metrics and alarms, I see one issue with this as well for detection is what if we push a change like by night, for instance? So you might not be aware of it before like the morning flow of requests stress your system, right? So that's where most of the time what I advise to my customers is to set up like a synthetic traffic. So one good way to do it like is with CloudWatch Synthetics, for instance, where you can like mimic your real customer behavior. And thanks to that, not have to wait for real customer to hit the issue. So that can be like a way to mitigate, for instance, the time it took for in your specific example to detect your basket issue. If we put in place like synthetics test that would like try to change the value of your basket and so on, we might be aware of the issue a lot ahead of what our users are experiencing. So great. Now, as I said here, we saw how we can potentially detect quite quickly and reduce this MTTD, which is a mean time to detection. Let's see now how we would go around the mean time to identification. So the goal here is to really identify the root cause of the issue, to be able then to fix it, and for sure at the end verify it. So here we're going to really focus on this phase of identification. And to do so, there is one specific issue that I see a lot currently in my customer setup, is the fact that we rely more and more on third-party services that are on managed services on our cloud provider, as well as we tend to go as well for microservices setup, which for the one that already had a problem in production, and I'm pretty sure that it's the case for most of us, it's getting really difficult to really identify where the issue is. Okay, we have an alarm on our API gateway saying that we are sending back 500, but is it an issue with our backend service? Is it an issue with our database, and so on? So one way to mitigate this issue is to shift the view from the per service metrics that we were describing before to a per request. And the way to do that is to set up what we call tracing. So a trace is basically a data that enables you to describe the different paths that a request from one of your customer is doing through your system. So we use, like, we have the capability to see different segments and subsegments that will give you like a better view of really what are the different steps that the request is taking, and therefore potentially identify quickly what is the fault in the path of the request. So here is an example of a trace going through a Lambda function, so which is a simple compute service that is doing like that can hold your business logic and getting like an object on S3, which is our object storage solution, where you can store files basically. And so here we can see all the details about how long it took to spin up the runtime, how long it took to request, to do the overall request, and then we can have like a specific information about how long it took to get to the object, for instance, that we are trying to get, and as well like potentially where is the issue. So great, here we see that the issue is on the Lambda function failing to get the object. So now we can dig directly into this component here, into this Lambda function, for instance, and get into deep and go deeper into the analysis. And one great way to go deeper then is to move from this trace view to the log view. So what you want to be able to do here is be able to move from this tracing to this log view. And to do so, the best is to have like what we call structure logging, where you will be able to put like, you will be able to search around your logs efficiently. Because for most of you that are using AWS or any other cloud services or microservices environment, especially, you might have realized that you end up with a lot of fragmented logs all over, like from your different services, the different instances of each services, and it gets really hard to consolidate them together and to really be able to browse efficiently. So one way to do that is really to leverage structure logging at each of your application level. So each of your service should follow a common pattern of logging, and that will give you the capability to really quickly search for an issue. As well as potentially, if you have like your trace ID as part of your message, you potentially can jump directly from your trace to your logs and get really quickly to the bottom of your issue. And one service that I really like to do that, it's CloudWatch Service Lens and the map option of it, which was launched, I think, 2 years ago. And that give you really this capability to bring together all what I described so far, which are the metrics you have, your alarms, your logs, your traces, all into a single dashboard. That looks like this one. So basically here you can see like our service with like different clients ending up into your application through different medium, and then you have like all the request flow in a single pane of glass here. With like, if you click here, you can see that there is potentially an alarm on my DynamoDB table, an issue with my S3 buckets. And then if you click there, you will be able to see like the log associated to it directly through traces and you're logging from your service that's called this specific system. So yeah, to summarize here, what would it would look like if we compare like a typical monitoring way and with observability tools in place. That's what it would look like. The fact that you are having like proper tracing logs and all under with proper correlation capability give you really capability to really reduce a lot your identification phase. And having like proper synthetics and insight information at your business level give you as well a really better way to get to the detection part of your resolution system. So
an interesting thing
yeah,
for synthetics, because a lot of people might not know this. Synthetics actually runs a real browser in the background. It runs Chrome.
Yeah,
and
exactly.
You can use Selenium type queries. You're actually testing, and no matter if it's a React application or something else, you can actually get really good insights into what's happening.
True thing. And it's always as well like used a lot with like if you have like third parties, like let's say for instance for your website, your e-commerce website, you're relying on a third party to handle payment, for instance, because you don't want to have to deal with PCI compliance and stuff like that. So for instance, Stripes or any other kind of third party services. You won't potentially see it failing. So that's really the kind of stuff you can use to monitor your third party as well. Like you can have like a synthetic traffic sent to your third party provider APIs and check if they are going well, and so be aware of it ahead of time again to make sure that you cope as well with third parties issues. So yeah, I just would like to come back on. So what would be a troubleshooting workflow on a properly instrumented system? Would be like you will have an alarm really quickly coming up thanks to the different metrics you've put in place and your synthetics traffic that you created. You would go to a service map to identify what is a real point of that create this issue, and potentially dig into the traces themselves to really identify like the different services impacted. You can even like go through deeper analysis if you need to, between like for instance, two releases of your software or stuff like that. You can have like performance as well and analysis that can be done at this level. And then at the end, you should be able to jump really quickly to the specific log that will give you like the stack trace of your issue. And that's bring us to what basically we tends to define as observability, is this capability to combine your metrics, logs, and traces, which are three really different kind of data with different like granularity and velocity. Like metrics are most of the time like aggregated data that are stored somewhere, where logs are and they are really like seeing a specific element of your system, where like logs are really text-based records that are really tied to your code itself, and traces that really represent more like as it's stated here, like the user journey across your system. And so combining all that give you really a better view of your system health. So if you want to play with all the services I mentioned and the one you will see in the next demo we're going to see, I strongly advise you to look into those 2 workshops. They are really good, and I participated to write some of those pieces as well. So it's quite fun to go through, and it's a website where you can rent pets, and we generate issues, and you can experience the debugging features that I mentioned during this talk. And yeah, I wanted as well to mention that here I talked a lot about CloudWatch services, but the point is not really observability can be done with a lot more than what AWS provide, and there is a lot of open source services that companies use today to achieve the same kind of behavior, and so we integrate quite well as well with those like OpenTelemetry and Prometheus and Grafana, for instance, to just mention some of them. So yeah, everything, I mean, putting in place any of those would help you in production for sure. And you might notice here, there is like a machine learning as well, elements that I think is really interesting. Just one other thing I wanted to mention is a new service that came out in AWS portfolio in the last reInvent is Devops Guru. And so where I find it interesting is the fact that it's bringing like a new element to the observability aspects, which is, okay, so Devops Guru basically is analyzing your different metrics from CloudWatch. And based on, so it correlates what a service is, complete service is based on what a CloudFormation stack describe. So even if you have like a microservices environment, it will be seen as a single service at this level, thanks to this aggregation in CloudWatch. But what's I think really interesting is the fact that it can correlate with another aspect that I didn't mention, which is CloudTrail or any like change on your system. Let's say you do a push in production, and so you change a specific elements. Like for instance, if we take this example, you change the DynamoDB read capacity, for instance. Here, CloudWatch, instead of firing you like thousands of alarms saying that now your Lambda can't write anymore to Dynamo, and then you get a 500 because Lambda can't get to Dynamo, and so on and so on, and you end up with like 10 alarms saying that something is wrong. CloudWatch with Devops Guru, what it will do, it will just fire one alarm that says, oh, someone changed the read capacity at the moment just before all this issue happens. So we really believe that that's what your issue is, and here and it hides for you like all the alarms that are fired, and just give you like this insight that, oh, this change really broke your system. So my point here is really, I think there is one more thing that we should consider when we talk about an observable system is, in addition to your system health as well, is what are the elements that change from your business side. Like if you activate a feature flag, for instance, or if you deploy a new service, or you modify one, and so on. And that can give you as well like a quicker way to figure out what's wrong. So yeah, that's mainly it on my side. If you have any question, please go ahead.
I'm looking here, no questions yet, so I invite any additional questions from the participants is there. Catalin, might you have any questions at this point?
Yeah, I think it's useful for everybody to understand these tools. What programming languages can I use with them? Because we have teams using Python, PHP, Node.js, Java.
Yeah, good question. So I think it's not really related to any language in particular. Like, I mean, if you take the example of metrics, for instance, if you want to create metrics in CloudWatch, one really efficient way to do that from your system is to use like embedded metrics format. So if you structure your log in a specific way with a specific schema that CloudWatch can understand. So it's a single string, it's a JSON-based string that you just fire out with a system LN or whatever language you're using, like a console log or whatever, and that will spin up that will aggregate your metrics on CloudWatch side easily. So you're not tied to any specific language as far as if you can spin up this specific string, you're good. So that's for CloudWatch. After for tracing is a bit more trickier because you need to have like the X-Ray SDK supported if you want to do it easily. It's feasible by API. We have APIs that any language can implement, but I worked a bit with those APIs. It's a bit more complicated. You need to handle authentication and so on. So it's a bit more tricky. But if you are like in supported language and I think today we've got Go, Python, Java, Node.js, and probably Ruby as well, and .NET for sure. So if you stay in the main languages, I would say you should be covered as well at X-Ray level.
One interesting thing, because we have a lot of projects in PHP, there's actually a community version of that SDK available, which works. So no fears if you're using PHP.
There's also a question in the chat there. Is there a way to play with these things for free, just to learning more on them, where you're not a student anymore?
Yeah, definitely. Like if you open an AWS account, by default, you're gonna have a free tier available, so you wouldn't have to pay anything. So I'm posting back in the no, it's for Penalist. Penalist app. Let me post it here. Yeah, so if those workshops won't cost you anything. If you have a brand new AWS account, you will have a free tier, and you probably can run across all of them quite easy. You can run them for free, especially the serverless one, where all services have extended free tier.
Actually, the demo today is serverless.
Oh, cool.
And what's going to be interesting is that serverless itself, it's extremely cheap. Also, you get with the free tier from AWS, you get like, I'm approximating here, about 1 million free requests for Lambda and DynamoDB. So you're definitely free for experimenting. And the reason why I suggest things like X-Ray and CloudWatch to all of the teams inside Pentalog is that it is, in some cases, free or nearly free. And other tools that might be more flashy, maybe look a little bit better, have some extra functions, those are extremely pricey. So I want to make sure that everybody of our colleagues, everyone has these tools available when they'll need it. If you can have fancier options, that's fine as well. But I want to start with something already there, regardless of what type of project it is.
Yeah.
And I guess this brings me to another question that people might be interested in finding out. So, Florian, is this limited, because we're talking right now about serverless, is this limited to serverless, or is it open to other things?
Not at all. So for X-Ray, for instance, so for metrics, again, it's if you're working with managed services, you will get like metrics provided by the service itself. So you will have like by default, DynamoDB will give you like a bunch of metrics. If you use and for like higher level of abstraction kind of service, like a Lambda, for instance, yeah, you will get a lot basically out of the box by the service. But if you're using like lower level services like EC2, for instance, you can easily add like CloudWatch agent into your operating system, and then forward logs and metrics and all that to CloudWatch the same way, and get the same level of metrics that you would have on a managed service. Just the point is you have to do it a bit more yourself than if you are using like a managed service. But and even this CloudWatch agent is something that you can install even on your on-premise services. We have a lot of customers, for instance, that are having like hybrid environments and they don't want to have 10 tools to monitor their system, and so they leverage CloudWatch too thin metrics there. And it's the same for X-ray. X-ray can be installed as an agent, as a sidecar, for instance, in a container-based environment, or it can be as well like a daemon on your machine that's forward traces. So there is no limitation in terms of regarding that.
That sounds great. I'm seeing also my colleagues posting the trends for 2021. If you want to check that out and subscribe to see more of the PentaBARs. And just before switching to the demo, I just want to frame a bit the discussion and maybe help us to have it better. So I'll return the question to our participants and just, looking broadly at the subject of observability with AWS, from a scale from 1 to 10, how much have you tried it, or what's your already practical experience with this? So if you can just put in the chat, you can put it on just for the panelists or for everybody. From a scale from 1 to 10, what's your experience already with observability at large in Amazon Web Services also? So I'm seeing some responses. I'm just having some more. It's a great variability of responses. So we're seeing some on the panelists. You can write it to everyone or to the panelists as you feel. I'm seeing from 1 to 10 actually. So just please give us a grip on where you are, just to know how we calibrate the discussion. And maybe after we're doing this, what would be important is, to frame it, what would you need in order to better understand it as a subject? So what would you need to just make your next step towards this subject? And if you can write also to the panelists or everyone, what would you need? Maybe a hint, you're just discovering it now. What would you need in order to make another step to it? And we're preparing for the demo, and in function of your numbers here and responses, will calibrate a bit the speed and the level of information. So, Florian, Catalin, back at you.
All right. Shall we move on to the demo part?
Yeah, I think it's, yeah. We're seeing, I'm seeing a question. I imagine is the difference between observability and predictability. I don't know what, maybe the hashtag is about that. So can you answer to that?
Yeah, so I would say that
the difference between observability and predictability.
Here, if we stick to the services I presented, like not going to the AI part and so on, I think really observability will be to give you a sense of your health of your system at T0, like where you are at the moment, and not really in advance of what's happening. After, it's up to you to be able to anticipate this kind of stuff. Like for instance, if you take the example of, let's say you have a matrix around disk size, and you see that it's like a linear kind of progress, you know that you're going to hit the limits. So it's up to you to put the right thresholds and understanding like that in advance based on what you put as metrics and alarms. But I think it's interesting because with all the AI services that are coming, and not only in AWS, like many services now are catching up on this as well. And we see a lot more on this predictability part, where you see, like, as I mentioned here, the anomaly detection that you can have on any CloudWatch metrics that can give you like really like prediction on is your system's going to fail. it's really something that is coming up. And I think it's just for now a bit of the premise of it, not really like we see, for instance, Devops Guru that is definitely into, you can have like a proactive action and even predictive, so kind of hints that the system can give you. But for now, it's still in preview. And so we see that the next step beyond after having an observable system. But I think it's a prerequisite to be able to have these data to train those models and get to a predictable one.
So we had other reactions, which is very nice. Some use it in real projects, some are just starting with the subject. And also to my question, if you didn't watch this in the beginning, because I've seen some participants watching, please subscribe to the link that our colleagues put it there, and you can watch the registration after the recording and more of this stuff in PentaBARs. And now another question, how it impacts business logic implementation. How not to gun-foot ourselves when building regarding observability?
Yeah, that's a good question. So if we take the example of adding tracing, for instance, in your system, you have two ways of doing it. And probably Catalin will present that in the demo as well at some point. Either you can, for instance, if we take the AWS Extra SDK, you have a feature that just say, wrap any AWS call that is made. And that you have one line of change to do in your business code to make your system record all traces going out of your service, for instance. And thanks to that, that will create the segment I was mentioning before automatically, and you don't change your business logic at all. But if you want like more granular stuff, or if you are calling like services that are not supported out of the box by X-Ray, then you will have to add like small pieces of code here and there to encapsulate your different behavior in your business logic. But at the end, it shouldn't change at all your business logic to have this kind of instrumentation. The only thing you're doing here is wrapping code around piece of code that will be able to get this start time, end time, and send these traces to a tracing system. But so
I guess
yeah, go for it.
There's one small addition here where if we follow the best practices that you have presented, we introduce a lot of business metrics.
Yeah.
So that means that we would, when in processing our business logic, we would add specific calls to send a metric to, let's say, CloudWatch, because we're interested in seeing that inside the dashboard and being able to do rules and statistics on it.
Mm-hmm.
One thing I'll mention really quickly on that one is where to not gun foot, as you mentioned, as it was mentioned in the question. Like one mistake that we see sometimes be done is, for instance, to create a CloudWatch metrics, some developer would use the put metrics, the API, for instance. So you have two ways of creating a metrics in CloudWatch. As I said, there is just spinning a log with the right format, or calling the put metrics, the API to CloudWatch. The issue is this API is a synchronous call, and it has a rate limit on CloudWatch control plane. So you can kill your application by, or slowing down your application a lot just by trying to put metrics. So that's where it needs to be done like really the proper way to not really impact your business application. Okay. Just wanted to highlight that.
So like an example would be a queue system, etc.
Yeah, or really, as I said, yeah, for metrics, for instance, leverage embedded metrics format, and that's all. You don't have, it's not an extra cost or anything, and you don't have to build a complex system to ingest your stuff. It's just your logging mechanism, and there is no rate limit on that one.
I would park if there are any other questions, so keep them coming. We'll address them at the end. Let's switch a bit to the demo and see what it brings on the table.
So let me share my screen. This is, let me know if it's visible.
Yeah, it's working now.
Perfect. So just an overview of what we are going to have in the demo as
Maybe
components.
Just a bit of a zoom would help. Yeah.
Perfect. Good. So just a little bit of an overview. We're going to have three services that we're going to be working with today. We have an order service, a cart service, and a coupon service. And of course, everything is serverless, wrapped around an API gateway, and our data store is going to be DynamoDB. Now, to come back to the scenario we're having today is we had this bug where we tried to change the quantity for our cart, right? So assuming that we have a cart which is with a few items, and we identify our items via, an array or a dictionary a key, and we just want to change it to a specific value. So this is the only information we see from the ticket. The customer is trying to change the quantity and it's failing, right? So if I'm just going to minimize this a little bit so I can click send, we can see that, and I don't mind how much it takes. It's the lowest amount of memory I put on the Lambda function. So, and this is also a cold start. So as we can see, we're changing the quantity on the first product to 2, and we can put it, I don't know, we can put something like 3, 4, let's go with 3. We see it's working, right? By default, everything is with 2, with quantity of 1. So again, I can vary this, nothing's going to change. I can't replicate the bug, it's been 2 days, right? What actually is happening is going to be visible as soon as we are going to be entering CloudWire Service Lens. So I'm going to quickly run the request as the client would do it. We're going to see an internal error. And now we're going to load the Service Lens dashboard and see what's happening. My computer is running a bit slow because I'm sharing my screen. All right, so we have Service Maps. We're going to want to go into Service Map. And we will be zooming in on the last 5 minutes because I'll be having a lot of tests for the demo in here. It's gonna draw our results. Alrighty, so what we have in here, we have our first Lambda function being called, which is called cart. It's a cart function, and this is normally what we'll be inspecting. This is what will be, okay, the cart isn't working, so I'm going to look at the cart. But actually, the cart isn't really the issue because we can see multiple requests here. Just part of them are failing, right? Only 25% of them. So definitely, if we look further downstream, we can see the coupon function is being 100% error rate, right? So obviously, this is not that awesome. Let's go with the view traces and see specifically what's going on with this service. All right, so we have an error. We're going to click this trace and we're going to see everything in segments, as Florian said. So we have the service map still here, and now we have each segment, right? We have an error in the segment for cart, and now we go into coupon. And with coupon, we're going to have an error with something like, where are you? There we go. Coupon not valid for this product. Obviously, if you have a production system, you're going to have a bunch of logs and you're not going to be able to look for all of them. If you have 10,000 people ordering stuff, it's just a huge amount of logs you're not going to be able to go through. And you might have, you can't search for error because it's probably going to show 1,000 results anyway. So being able to see error rates and going back to what service is causing this, we can see exactly the message and of course the logs. The logs, as Florian said, everything that has happened from this service. So now we can take a look at our code. And I'll go through each of this because I want to show you how we set this one up. But now I don't have to go to cart specifically, right? Because I can go to cart, I can see that it has a bunch of code, but I don't know where the error is coming from. But if I go to coupons with the right error message, coupon not valid for this product, I understand that I either have to add some proper error handling here, so fail silently, or just remove this or do something else in the cart to handle this, but it's not something from the cart. And this might seem a very simple example. It's supposed to be. In real life, you probably have a bunch of, let's say 10 or 20 interactions between services, real life services and modules. So that means it's very hard to spot. Right. So
yeah,
that would be
just to add one more thing here. I think in a real system where really is a game changer here is really this capability to jump from your trace that you just mentioned, where you've got like your error message, to really the logs that are behind it and potentially see the logs across after, like if you go to CloudWatch Log Insight, for instance, or which enable you to search for logs across different services, you can potentially retrieve all the logs for a specific request, and so get really to the bottom of your issue. So really these links between the trace and your logs that are, as you said, enormous amounts, is really what, for my point of view, at least when I was in operation, makes the real difference in debugging.
Right. So no matter how many services, microservices you have, how many components, it means that when a customer requests something, I can see all the logs from all of them in one place for that customer.
Exactly.
Perfect. So that is really a game changer. And I'm sure everybody with debugging production issues will agree with that. So again, my computer is a bit slow because I'm sharing my screen. But we can see that we have request IDs, and we can play around with an SQL-like syntax, let's say, and we can run queries on our logs. Perfect. Right. So I guess the client will be happy and the product owners because we finally found the issue. And this was a bit more simple. How about we try something a little bit harder?
Yeah, cool.
Let's say we have issues with our administration page, and specifically admins cannot see new orders. And obviously we received a bug, but since we're in a different time zone than maybe the clientele and the admins, when we try to look at it, it's working pretty fine, right? So this is just dumping out some things we have in DynamoDB. So we have items, we have the client ID. This is data. This is basically representing some encoded order data that's going to be decoded and then shown in the display. We have an order date, which is our sort key, and we basically have a bunch of these. So we can see that it's retrieving a lot of data, almost a megabyte of data, quite a few things, and it's working just fine, right? But that's because, let's say, this customer is in America and its client base is located in America, and we're basically testing it. Well, actually, I shouldn't give away the reason. So let's replicate the bug. Let's say that you have a bunch of customers coming in, rush hour, they're ordering things the same time. Let's say it's lunch, and they're doing. So this is very slow. Let me do it from the browser, because the browser is going to allow me to do a lot of requests by hitting F5 really quickly or something like this. So I'm just refreshing, I'm typing really fast, I'm doing a bunch of requests. I'm simulating. This is the most basic load testing you can do, right? I'm doing a bunch of stuff. Let's see if it's still working right now. So it seems to be a bit slow. Let's see if it returns an error or not. And this was actually a very hard bug to make happen, and I'll explain afterwards why. It's because AWS services are getting better and better. Okay, so now we have an error. So when we tested it ourselves, when we debugged it, nothing happened. But when real customer traffic is coming, a lot of people, there's an error. All right, and I'll also point you to my inbox. There's nothing in here right now, but by following best practices presented by Florian, there soon won't be, right? So we got an error over here. In about a minute, I'll receive an email. Okay, so let's take a look at what's happening. And in any second now. Because right now, if the traffic is going away, I'll soon be able to refresh. We can go to service lens, service map again. We're going to go with the last 5 minutes. Okay, so we're now seeing a different microservice. We're seeing the orders microservice. We can see a part of the requests are working, a part of them are failing. And we're seeing something very interesting over here. We have a DynamoDB table, our database. It has an alarm on it. And if we click it really fast, we can go and see what's happening in our trace. Actually, let's go to trace right now. This is really nice because, again, when you have tens of hundreds of requests, we can definitely filter them by client ID or by, let's say, if there's an error or not. And we can definitely see there's been some errors, right? 2.8 minutes. This seems to be one of the, let's go back and get something, the latest one. I don't know if this one that was a little bit early. 3.something, 3.2, 3.2, that's 2.1. That's some of the earliest errors. Right. An error occurred. Provision throughput exceeded exception when calling execute statement operation. All right. So it definitely is showing us that we have an error. It's in DynamoDB, and the culprit is provision throughput exceeded. And if we take a look at my wonderful inbox, we can see that a couple of minutes ago, we actually received an email that says, you know, there's a problem. There's an alarm going off. There's throttle events in your database. Go fix it. Obviously, this is a great thing because it actually shows me that I have alerts. It's not just a simple problem. I also have alerts, alarms going off for DynamoDB. So I know it's serious and I know exactly where to look. And I promised I would tell you why this was a hard bug to make happen. Because in DynamoDB, if we go to it, we actually have, I'll actually show you the code because it's easier to do. We actually have a very, very small number of, we just have one read consumption unit or RCU, presentation mode. which means that normally this should, a few years ago, with capacity as one, would have failed quite easily just after a couple of 1 or 2 requests, because I have a lot of data in those tables, and each RCU can support reading a certain amount of kilobytes from the table. However, recently, DynamoDB has added 2 interesting features. First, it's the concept of a token bucket. So the same thing that happens with your burstable instances, where even if you go over your provision amount, it actually allows you to get away with it, right? To handle burstable loads for a set amount of time. And so that means I can go like 10, 20 times higher for a short amount of time, which I did. And second is the introduction of automatic retries. So that means it's trying to, no matter what is failing, it's trying to handle the request for you. And that's why it was waiting a long while, as we saw in the browser, which made it really hard because we had to do a lot of extra requests, even though it was supposed to be failing immediately. So that was pretty nice. Cool.
The automatic retry was part of the SDK?
No. Yeah, I mean, yes, it's part of the SDK, the DynamoDB SDK. Okay. Because I'm using Boto-free.
Exactly, like here to solve your issue, you would have like several solutions. Either extend your RCU, or as well, like you can customize your retry policy to retry it. So the back-off retry mechanism to extend even more the number of retries.
Honestly, DynamoDB is super cheap. So as you said, that's all valid solutions. But I usually just start out because you're not going to know what traffic pattern you have. So you just like go with pay-per-request. Yeah, it's more expensive, obviously, but if you're not at a huge scale, you won't notice. Obviously, DynamoDB is cheap anyway. So yeah. And then you can go with provision. You can set up auto scaling. That's also a nice feature. But honestly, usually it's not worth mentioning. You just go with provision capacity, and when you're gonna make big bucks having a lot of clients, then you'll worry about reducing costs later. All right, so I also promised I'll be showing you the code for this demo, because this wasn't done in the console. Everything was done via infrastructure as code. And you can see how easy it is to implement it as well on your projects. So what I'm using here is called CDK, the Cloud Development Kit. It's been out for a while, 1+ years, and we've been using it since it actually went out. It's been a great addition to our toolbox. So for those who don't know what infrastructure as code means, it means we are using code to provision infrastructure. We're not doing it manually. And that allows us to, of course, use the same practices as we do for normal code. So we're writing it in an editor. We're pushing it in Git. We're having peer reviews, stuff like that. But CDK is awesome, and it's much better than CloudFormation or Terraform. And I know, send me the hate later. For all those fans of Terraform, but actually using real code instead of YAML is a game changer. So this version is in TypeScript. You can also use it in Java, Python, C#, I believe. Don't quote me on that. I've never used it.
Yes, you can.
So yeah.
I agree.
Oh, awesome. There you go for the people using C#. So you have a lot of options. JavaScript and TypeScript. I like TypeScript because with an editor, if I mess something up, if I forget anything, if I just, I don't know, let's put in here 0. An editor is going to say, oops, you've done something bad, right? You're supposed to bring a number here. You're not supposed to, you're not supposed to do a number. You're supposed to do a string. And of course, all the type hinting and seeing what you're supposed to put. It's so much better than deploying and finding out silly stuff like this is what crashed. What prevented you from deploying your CloudFormation template. And this gets compiled down to CloudFormation, but it's much better to just use a real programming language. So you can see here a bunch of packages that I'm importing. the database, an API gateway, a custom level 3 construct, and I'll be showing this right after we go through this file. CloudWatch actions, SNS. So there's a whole documentation website. If you just Google search for CDK API, AWS CDK API, and this is how easy it is to create a table. So this is a DynamoDB table. Obviously, we're defining our initial key, our primary key, and our sort key or range key. DynamoDB has a NoSQL, as any NoSQL database that's worth its salt has basically 1 or 2 parameters that you can fetch data with. There's a bunch of fancy stuff you can do with it. I guess one good resource is DynamoDB office hours, but for now we're just going to fix this by adding a 0, and that's going to fix our read capacity so that it doesn't fail anymore. And if we really wanted to fix it, we would go pay per request, right? Because then we won't care. It's gonna allow as much usage as you need, and you don't care about read and write capacity anymore. And you just put the command, and that's how you fix it after you identify the issue. To set up monitoring on a DynamoDB table, you can see here I'm referencing it, and I'm actually using an already existing CloudWatch metric, because any AWS service that you provision comes with a bunch of them, and they're free. That's the best part. That's why I say, everybody should learn to use CloudWatch. Have as many other external tools as you want and feel like you need, but whatever you do, know about them, know how to use them, and have them set up in the case where they do need to be set up, because they're extremely easy to have on projects. You don't need to request a ton of approvals or any approval usually, because they don't cost money. They're already there. So in this case, we're using rethrottle events, and we're creating an alarm. We're setting it to 1 evaluation period, which that means, if the metric goes above 0 for 1 minute, and it sends an alarm, and that means we're going to be using SNS to send an email, and you can see my email here. We just add a subscription to this SNS topic. And for the alarm, we're adding an alarm action, which you can do a bunch of things. You can, it's not just limited to SNS. It's not just limited to email, but this is the most simple example we could present today. So we have the monitoring part for DynamoDB. This is 10 lines of code. Granted, this could be minimized, but I don't want to, go over this limit too much. We have our API gateway, and this is the new HTTP API. This is different than the version 1. You can see we're using version 2 here. HTTP APIs are much cheaper, but they're not meant for REST. It's not like all the fancy stuff you get with the version 1 REST API, let's say. This is for more specific use cases when you want extremely low latency and extremely low price. Okay, and then we add our services. You can see here that we're passing in our API gateway, and we're even specifying what routes it should be listening to. So this service is going to respond to these routes. That's a very crude routing mechanism. And we're passing in some environment variables, such as like the DynamoDB table, the API gateway. And for our order service, we're going to need to know to do some, basic, I wouldn't call it service discovery. We're going to have to link them together so they know how to call each other, right? So the order needs to know where the coupon service is. And this is pretty simple. This is basically exactly the same thing. And obviously, since we want to leverage as much as possible CDK, we're using it to grant access to the database table and to the function. So it's very secure. You have to specify what permissions to have, and usually it's a bit more tedious in going to, having an IAM JSON that you have to put there, but this makes it real easy, right? This would be, I don't know, 10 lines of JSON. Here it's just grant this access. That's it. So that's very cool. And yeah.
It's very engaging, I believe, for everyone, but just because we contracted 1 hour with the participants, let's try to wrap it up and answer some questions. Some are leaving and I want to have the question.
Perfect. So that means I'll introduce the level 3 constructs in just 30 seconds.
Yeah.
Using something like a real programming language allows you to abstract and create your own components. So this is actually very easy to call again. And this is our wonderful microservice. All of them are made this way. All we have to do to enable tracing is to put this on. And the rest is pretty much handled. You have metrics and logs by default. So I guess that's it. That would be the demo. I hope you enjoyed it. And I'm going to stop my screen sharing. So, oh, never mind. Wrong button.
Stopping the camera and not the screen.
That's how you know it's live.
Yeah, it's working anyhow. Thank you for that, Catalin. I've seen Florian answered a bit some of the questions in the chat or engage interaction. Do you want to select any to present to everyone, or?
Yeah, maybe one that I found quite interesting. Is there a proper moment when we should set up an access observable services? Is from the start of the project or afterwards? I would say is a bit like unit testing and stuff like that. If you postpone this setup, you potentially never ending doing it before you really end up having complex issue in production, and it's going to be too late. So the sooner the better. That's what I would say, and that will force you as well to really understand what you're doing, especially if you're using managed services and so on. At least thinking about what is a KPI, what are the limits of a system, and so on. Is always a good thing. As we have seen here, if you, for instance, if you create a DynamoDB table with CDK, by default, it's going to be like 5 read, 5 write. It seems to be right at the beginning, but you might quickly end up having like issues with your read capacity and so on. So having like this monitoring dashboard in place and an observability system in place will force you at least to try to understand what you're using. And so I think it's really important to put at the earliest in your project, to set up as the earliest in your project.
So thank you for that, Florian. Thank you, Catalin. I do hope this is a subject that will go on and develop over the time. Please answer it just for questions. Also, our questionnaire about the feedback. It will help us a lot to plan future pentabars and address the subjects. I just put you here. It's 4 questions. It takes less than a minute, but it will help us a lot. And see you next Wednesday. Hopefully my internet connection will be good enough. And see you in the next PentaBAR with another interesting subject. Bye for now.
Bye.